It should be no surprise that every year millions of Americans flock by foot, bike, horse, or other modes of travel across trails of parks and protected areas. These veins or pathways of our park systems are experiencing ever-growing use, which can lead to negative effects on the trail. So, how do natural resource managers begin to understand the forces that change trails over time? Do certain activity types impact trails more than others? Do natural resource managers begin to mitigate these challenges? How do they do so? These are just some of the questions we try to address in this method video on conducting a trail use assessment. Good day, everyone. My name is Ben Fowler, and I am a doctoral student under the direction of Dr. Matthew Brownlee in the Park Solutions Lab. My lesson today will focus on a specific analytical method researchers and natural resource managers can use to evaluate changes in trail conditions over time. This trail assessment method, for the purpose of this video, will be called trail transecting. To give context and importance to this method, do your best to think of a time you were out hiking or recreating on a specific trail in the woods or within a park and protected area. Did you notice that not all sections of the trail were homogeneous in their condition, aesthetic, or general quality? In other words, you may have noticed some sections of the trail were eroded, muddy, clogged with deadfall or woody debris. Some trails noticeably may have been altered by a specific activity type, such as hiking around a muddy section which expands the trail width, or mountain bike tires or horse hooves creating deep incisions in the trail. In sum, these issues are problematic to natural resource managers because deteriorating trail conditions can threaten a fragile ecosystem and the overall visitor experience. Before we begin our path toward digging deeper into the trail transecting method, I'd like to highlight the main objectives of this instructional video. Objective number 1. Provide a cursory or introductory description of the basic trail transecting methods and the materials required. Number 2. Utilize in-the-field or real-world video footage of the trail transecting method to offer a richer visual depth to the method. Number 3. Discuss a few limitations of the method and supply additional resources for further investigation. So, let's get started with the description of the method. First, trail transecting is an essential element of visitor impact monitoring for natural resource managers. Typically, natural resource managers will employ this method when wanting to identify the relations between levels or frequency of trail use, activity type, and trail condition over time. Marion et al. Stated, trail impact assessments and monitoring seek to describe resource conditions and impacts for the purpose of documenting trends and trail conditions, investigating relationships with influential factors, and evaluating current conditions in light of management standards of the quality or the efficacy of corrective actions. Before we highlight the main elements of trail transecting, I'd like to discuss a few essential materials or gear items needed to conduct this research appropriately in the field. So, essential trail transect gear. As you can see in this moderately organized gear explosion, the research team has several items of essential gear needed for trail transecting as depicted in this photo. Essential trail transecting items include Please also remember before heading out into the field for research to leave a detailed trip itinerary with your supervisor, wear proper clothing, make sure your med kit is fully stocked, and have adequate amounts of water and food. Conducting trail transect measurements. A quick note, the trail transect methods described in this video have been simplified for brevity. Further inquiry into additional measurements and elements of this method can be explored using the resources provided at the end of the video. It is also important to define the following terms before we begin. Here are a glossary of important terms. Tread width. This is the gap in vegetation growth where the trail resides and is central to supporting the trail traffic. In other words, it's the cross-sectional width of the trail from one side of the trail to the other as determined by the vegetation line. Figure 3 here, taken from Mammoth Cave National Park Trail Monitoring Field Manual, can help visualize this concept. Maximum incision. The depth of the tread in relation to the sides of the trail. Incision correlates with soil loss caused by wind and water erosion, compaction, and soil displacement. Lastly, the cross-sectional area. The area of the trail cross-section determined through a formula of measuring the vertical distance from the tread width to the ground at several intervals. This is illustrated in Figure 4 from the Mammoth Cave National Park Trail Monitoring Field Manual. The following transect methods described and visualized in the field are from a research project collaboration between Mammoth Cave National Park and the Park Solution Lab at Clemson. A problem census approach compared to a random point sampling approach to establishing trail transect locations was agreed upon with management prior to data collection. Thus, the following steps provide detail on conducting a trail transect once a problem area in the trail has been found. I will describe the steps needed to determine tread width, maximum incision, and cross-sectional area, as well as the measure of slope of the trail using the clinometer. Each step will include short video segments of these measurements being taken in the field at Mammoth Cave National Park. Step 1. Hike to the trail problem area as determined in collaboration with management and begin organizing required gear as previously described. Step 2. Once the problem area and specific transect point of the trail is decided, begin filling out the trail transect data form as seen here with as much specificity and detail as possible. Once the preliminary data has been filled on the form, you are ready to begin collecting data on your first trail transect. Step 3. The first measurement taken, and this is the tread width. Standing in the trail with your 2 stakes and P-cord, set up the boundaries of the trail. These boundaries are defined as pronounced changes in ground vegetation height, cover, composition, or when vegetation cover is reduced or absent, as pronounced changes in organic litter. We see here that John and Kate have established the boundaries, inserted the stakes, and have begun to set up a taut P-cord and measuring tape spanning the trail width from stake to stake. He has used the binder clips to make the anchor points for the P-cord and measuring tape. Step 4. Once the initial setup is completed, the rigid steel tape is used to measure the actual tread width to the nearest quarter inch. Step 5. Once the tread width measurement is taken and recorded, the maximum incision is typically the middle or deepest part of the trail, is measured from the tread width line established above to the ground. Kate is seen here taking the measurement. Be sure to remove leaf litter or woody debris so as not to skew your measurement. Once the maximum incision measurement is taken and recorded, it is time to begin measuring the cross-sectional area. Here it is important to pick a point of reference as your starting point, such as up or down slope of the trail. The first and last measurement of the cross-sectional area are 0 for the vertical transect. Again, Figure 4 may help you visualize this. Continuing on, measurements are taken every 6 inches intervals until the entire cross-section span of the trail is measured. After all these measurements have been taken and recorded, you are nearly finished with the trail transect. The last step is to record the trail slope. The trail slope is recorded with the clinometer. 2 people of approximately the same height are needed. One person, John as seen here in this example, stands at the transect point as Cole takes 10 steps upslope of the trail. John records the slope as indicated by the clinometer and then repeats the process with Cole walking downslope 10 steps. This now concludes our basic trail transect method description. This concludes the trail transecting method description. I hope you have learned something on trail transecting within the last 9 minutes of your life. Again, this video method description was purely an introduction to the measurements and overall concept of trail transecting. I suggest consulting research articles by Dr. Jeffrey Marion, a recreation ecologist and one of the founders of this method. While this method is crucial to determining on-the-ground level data for trails, efforts are continually being made to address the accuracy and precision of trail transecting. As demonstrated in the video, much effort is made to be as organized and precise as possible, but there is substantial room for subjectivity or interpretation in many of these methods. Overall, refinement of these methods and additional research involving longitudinal data will allow natural resource managers to make informed decisions in hopes of conserving parks and protected areas for generations to come. Thank you.